Green.
Yeah, green is good.
John, is it?
Should be okay.
Can I start? Okay, I'd like to start by thanking Kenneth for the opportunity to do the site update. We already did this last year, so we have a few things that's changed, so I think it is worth to share these new things that we have at CSCS. The presentation will be divided in two parts, since Theo here is the guy who implemented the new things that we have at CSCS. I will be doing a more general site upgrade, so I'm the group lead of the scientific computing group support. Theo has joined the team since 5 months, right? So, but he already has some contributions to show you. So this is the outline for today's presentation. I will first present the timeline for the EasyBuild implementation at CSCS, and I will present two use cases. I will call it as use cases, the two main systems where we use EasyBuild, but we also have it on other systems. Then I will hand the presentation to Theo, and finally I will give some final considerations about EasyBuild at CSCS. So this is a rough timeline of EasyBuild at CSCS. It all started 3 years ago when Kenneth and Peter implemented the Cray support for EasyBuild. We started playing around, and by May 2015 we had Python, which was one of the main things that we had problem at the time of installing and maintaining, and we validated this successfully. So Python, it was a very good use case for starting EasyBuild at CSCS. And then the second use case in parallel with that, so the first it was on Pezzi, and the second one it was for Metal Swiss with a CS store machine. So the difference between the CS store machine comparing to Pezzi, which is a XC, is that they don't provide the full software stack. Cray doesn't provide programming environment and all the libraries as on the XC. So EasyBuild, I can say, as you all have already experienced, worked out of the box. We managed to install all the libraries for Metal Swiss quite easily, and it was quite successful. Then, and at September, we had finally the stable version of the Cray support of EasyBuild, and the 11th hackathon that it was at CSCS. By December 2016, so the year after, we had the main Pezzi upgrade, and this is a milestone that I wanted to put it here because this is when we had officially EasyBuild as the main tool for installing software. So it took roughly 1.5 years from the first attempt to the day where we say, okay, this is the official way the support team should install software at CSCS, is EasyBuild. And then since then we still are sticking to this rule. So we don't do manual builds anymore. Everything goes through EasyBuild. And right now, as of today, besides EasyBuild, we also have on top of that Jenkins that is automating the installation of software. So we have a team of, including me, we are 12 people installing software at CSCS, and none of us is actually installing software. We just prepared the recipes, and Jenkins is installing everything for us. So Theo will show you how this is done. And before it was with the old style Jenkins projects. Now we use pipelines. It's more modern, and we also have version control for the setups and for all the installation. So this is a slide from last year that I wanted to keep just to acknowledge the Cray support, that we are here thanks to Kenneth and Peter. So they implemented things that can also be used on non-Cray systems, like the support for external module files. So if you want to use modules that you already have together with EasyBuild, you can do thanks to that. So this is a feature that it might be interesting for you as well. just to have an overview of the systems that we have at CSCS and the scope. So our flagship system is Pezzi. So it's a hybrid, it's a heterogeneous systems, one partition with accelerators, so GPUs, and one partition with only Broadwell compute nodes. Then we have Monk, which is specifically for projects. Then Asha and Cache are for a client, for Metal Swiss. They are dedicated systems. Then we have Leone, which is also for another client and for large memory use cases. So this is also from last year, but we have many people that were not here. So a few details on the Pezzi Cache and Asha. It's actually two cabinets for failover. So this is used for weather forecast in Switzerland, and this is a GPU dense system. So it's 8 K80s per node. So 16 GPUs per node, and this is in production since September 2015, and I can say it's pretty stable. And the main thing that EasyBuild helped us here is that it was a very new system when it was deployed. So the GCC provided by Cray at the time, it was unable to assemble AVX2 instructions, and they shipped a Haswell system that couldn't, with compilers that couldn't use actually the potential of the system. And with EasyBuild, it all worked out of the box. So before the same time we opened the ticket in Cray to solve this bug, when we got an answer, we had already the software stack with EasyBuild. So I mentioned Pezzi is heterogeneous systems. We have two. This is our flagship system that is part of Praise. We are a hosting member of the Praise project, and the largest partition that is dedicated for Praise is the XC50 partition with the Pascal GPUs, and then we have also a smaller multi-core partition with Broadwell, and the network is also with the Dragonfly topology and the Aries network from Cray. So the Pezzi is currently, this is not new, this is since 1 year more or less. We are number 3 on the top 500. We have 5,300. This is not the whole system, it's just the GPU partition with 5,300 nodes with one P100 each, so it's 19 petaflops. It's worth to mention that on the Green 500, we are one of the few large-scale machines that are also on the Green 500, because mostly the machines there are small systems with a few GPUs, a handful of GPUs, and Pezzi is one of the only large-scale system there. A list of software. This is just to give you an idea of which are our main customers. So we do a lot of material science. This list is also from last year, but we have new things here, mostly on the deep learning side. Also, these recipes are GPU enabled, and this is one thing that we see that we have an increasing number of requests of this kind of tools right now. So besides the classical HPC users, now we have this kind of requests. As Bart represented this morning, we have a similar dashboard in Grafana to monitor the usage of the package. We have Xalt, and then we can see which are the top applications and which applications we could maybe remove by the next upgrade. And this is also integrated with EasyBuild. Whenever we build a new application in production, we update the Xalt database so that we can see it here. If you want more details on that, you can just talk to us after. We can give the contacts of the person in charge. Another new thing since last year is that we are also providing EasyBuild to the users. So first, this was just an experiment. We said, why not giving the instructions to the user? EasyBuild targets more HPC sysadmins, and then we thought, why not? So we put this, and then after 1 year, we didn't really measure the usage, but one day we broke the module, this module that they were using. So let me go to, so they have this module called EasyBuild Custom. We broke this, and we noticed that we had a handful of tickets right away. So we noticed that people are actually using EasyBuild themselves. So it's a tool that you can also, on your sites, provide to the user. So for us, we consider as successful. So since we don't support all the software that people ask that is not scaling, we don't install it ourselves. For the not so popular software, we help them with the EasyBuild recipes. So we don't tell them, please do make, and then these complex things. We just do provide them an EasyBuild config. And then first time they need help, the second time when they need, they just update the recipe. Most of the users, not of all of them, of course, but this has been proven to be very productive. So next section is Theo, who will explain a little bit more how the Jenkins setup works.
So hello from me also. I joined recently CSCS at September, and I work for the scientific computing support team. And my task was actually to transfer and to migrate our Jenkins, the Jenkins use that we do, to use the more modern recipes in terms of pipelines. So I'm going to show you a little bit how we work with Jenkins and the underlying EasyBuild that we have installed to be able to install every software that is asked for us. So Jenkins at CSCS is the basic tool that we use for CI, and in order to deploy software packages, we use, of course, EasyBuild, which provides a unified experience for all scientific software installations. So at CSCS, we have 3 distinct Jenkins projects. The one is the testing, which is the actual CI project that tests every EasyConfig that is submitted at our production repository at GitHub. We have the production, which actually builds the software to be available as a module for users after we have tested it. And we have the regression one, which runs once a week and checks all the EasyConfigs that are available in production so that everything builds correctly. And my job actually was to migrate, as I said before, the Jenkins projects to use pipelines, which are a much better alternative. So they provide greater flexibility regarding the actions performed by Jenkins, and they have access through pipelines. You have access to the Jenkins API directly. Also, the Jenkins files, which are actually the recipes that describe how Jenkins, what actions Jenkins is going to take, are version controlled, so each one can monitor and see if there is a problem with the Jenkins file. And the other advantage is that they can easily run the Jenkins jobs in parallel and use all the available resources. So this is just a picture of the README that we have at our production repository, that we describe how you can submit a new pull request at GitHub with a new EasyConfig. And so the convention that we use is that the pull request message has to contain the name of the machine, that actually the list of the names of the machines that are actually going to be tested, where actually we are going to test the new EasyConfig. So to give you an example, we have this particular pull request, and on your left you see that we include Dynth GPU, which is actually the machine and the specific partition. And on your right you see the actual pipeline that is executed and by Jenkins, and you see here that Jenkins selects Dyn GPU to run it. If we have the convention that if the machine supports multiple configuration like Dyn, which has also GPU and multi-core partitions, if the user doesn't specify partition, this EasyConfig must be run on both partitions. So you see here that we have only Dyn. The user says that he wants to run the EasyConfig in Dyn, and so it runs in parallel by Jenkins in both Dyn GPU and Dyn MC. And I'm going to conclude by showing you how our regression works, where we test the production, the EasyConfigs available in production weekly in all our machines. So, as I said, it runs weekly by a cron job in weekends, so that it doesn't disturb the users. And you see here that it runs on each machine. And the thing here, the good thing is here is that we use the new Blue Ocean interface. You see here this 9 interface, where you can see if you click to a particular machine, you can see the console output and the EasyBuild, what failed, what went wrong. So yeah, because all these things run in parallel, if we didn't have the Blue Ocean, all the console output would be on top of each other, so you cannot easily recognize from which machine they came. So this is the alternative interface that they propose now with the pipelines. And that's it for me. So Guilherme is going to give the final remarks regarding our use of EasyBuild.
Okay, I'll try to go quickly because of time constraints. So as usual, the learning curve for using EasyBuild, it's what blocked most of the time for adopting EasyBuild at the beginning. So people are very resistant to change. So, and these things together is the most difficult thing in order to establish, to say, okay, this is the new way of doing stuff. So this is thought. And then the other thing that I'd like to discuss, or just put in the table, is the discussion between EasyConfigs and EasyBlocks. So we know that EasyBlocks are reusable, and they are great for well-packaged software. But in our experience, it's too much overhead if you use it for bleeding-edge software where things change all the time. So we spend time designing and writing the EasyBlock, but for the next version, you need to do it again. So. And also, you don't have track of changes because you don't see that on the log. So if you change your EasyBlock, you need to find a different way to keep track of the changes. And for the EasyConfigs, okay, you have duplication because people usually just copy and paste everything. You don't have generic things that can be reused, but you have self-contained recipe. And for a management point of view, this is really a big plus, because people can really see in one screen everything that should be done, and you don't have other steps that you need to look. So our wish list for this year, maybe we can discuss more in the hands-on. It's like this first one is the same from last year's. Whenever we have to upgrade a new software stack, it's really boring to go to every file and change all the dependencies. So if we had a command line to do that and change the dependencies also when you do try software version, we could have for dependency. We have already discussed with Damien this last year, but finally we didn't implement. Another suggestion that I have is to have a separate log with only the command lines performed by EB, as we do the extended dry run, and you say, okay, dry run is not 100% sure because you have missing information, but on the actual build, you could do that, I think. So it's one idea, and then people could use that to reproduce the build manually if they want to debug, or also people who are moving to EasyBuild and they don't understand what is happening on the background, this could also help.
With this you mean the commands that EasyBuild executes, not
Yes.
the output?
Yes, to separate, because if you mix both, it's really, the logs are huge.
Generate a script that you can then run.
Or look at least.
Or look
at least.
Yeah.
And then
close to extended dry run.
Yeah, exactly. Yeah. So then backup of custom easy blocks for reproducibility. This is, I think, from last year. I don't know if it's not on the log. So if you change your easy block,
If you do manual changes,
yeah,
no.
yeah. So that's why we prefer easy config.
You could have a Git repository with your easy blocks, the commits there, and just do
Yeah,
include
yeah.
easy blocks. Then
Okay,
you have
yeah.
the versioning as well. But you want them copied?
Yeah.
Like patch
As you
files?
have the EB REPL for the easy configs,
Okay.
it's not self-contained. If you have your build inside the EB REPL, you have your easy config, but not the easy block.
Yeah. So there's two potential issues there. Just copying the one easy block you're using may not be enough. Maybe using stuff for other easy blocks may also change.
Yeah, yeah.
And what if you change the framework? Are you going
No, I don't expect at this level, but custom easy blocks is something you have the option include easy blocks.
Yeah.
At least those that you use from the include easy blocks.
Copied everything together. This was how the build was done.
If you want,
Patch file, easy config file, easy block.
yeah.
Okay.
This is just one idea. And the other one, external modules, I think it's more for CSCS, since we use that often. We don't have error reporting. So if the module doesn't exist, you see in the log, but the build doesn't fail. We have something we need to maybe to discuss, or the version is missing. I think this needs to be more robust. Last topic, ongoing work. This is probably a topic that we will discuss next year. We just started deploying an HPC OpenStack with EasyBuild. So this is something that we are working on. Also, Peter, I think he's doing something similar. Okay, the last slide is only for a reference. So you want all of this Jenkins testing. It's all public. So if you want to see our configuration file, everything is public. There's nothing hidden on the server side. You can really just go there and see the files that you use. And if you have any question, just come to us. So I think that's all from my side. Time for.
Go back a couple of slides. There was something you mentioned. Another.
Yeah. More?
Yeah, one more. But no, that's too far.
Too far?
Yeah, here. I had a question. I forgot which one. Ah, right. So you don't like easy blocks because it's if you have to change them. Yeah, that's the reproducibility thing. So you want to have an archive of the easy block that was used, and maybe the ones underneath as well.
And the other thing is that not everyone, at least in my team, is it's proficient in Python. Yeah. So whenever we have a recipe that requires changing the easy block,
changing the logic,
we need to point always to the same people who know Python.
This is not something you can always fix in easy configs, right?
Often it is.
Config extremely complex.
Yeah, so you will just be writing Python code in easy config, or
not necessarily. No, we just. It could be that we are hacking too much, but we do everything we need.
Hard override, build options, configure options.
Exactly.
Stuff like this.
At least it's self-contained, even if it's not. It could be hacky.
So but this goes together with you're trying to avoid having to change easy blocks also because of reproducibility concerns.
Yeah, it's the two things together. Yeah.
Yeah.
And for some applications, we just do it quicker with the easy config. Yeah. So this is a matter of productivity.
And so the Python is an issue. A lot of people are not proficient enough in Python to change an easy block.
It doesn't need to be a lot, but there is this problem. So you need to think that not everyone is proficient in Python. And then for me as a manager, I know that I cannot count on all of them to change these files, while if it's an easy config, everyone can do it.
Is there another language that would be better suited?
No, and it would boil down to the same problem. So I don't think.
So one idea I've been playing around on, but I've never really did it. Is it's pretty easy to create a generic easy block, where each step just is a bash script that you run. And then it's very easy. Well, if people don't use bash, they probably shouldn't be working for CSCS. So I guess there it may be easier to do.
Yeah, could be, but as it is today, it's already, I think it's already good enough. We find our way out with the current easy blocks. Sometimes we use the command CP, which is when if everything else fails,
You're just working around.
yeah, and then it's just
It
like
gives you
Bash.
enough flexibility that you can get the job done, maybe in a dirty way. But yeah.
Yeah, for applications that are dirty, that they don't have a proper build system. So
Okay.
I suppose part of the problem is as well that if you have to do an easy block, you have to think about the logic. You have to think on this version I want it this way or this other way, with this compile I want it this way or this other way, and if you have it on the easy config, then that easy config is for that version, for that dependency, for that tool chain. You don't have to worry about all the other stuff, because what happens to me sometimes that I know I want it this way, and how do I put it together with what is already there? And that creates a little bit of overhead, so I guess it's also part of the concern, not so much maybe Python, well, I don't know, but I suppose it's more, at least for me, I see it as something more.
Fit in the current logic, and also how do I avoid breaking?
Exactly. Yeah.
So I think that's part of the.
You need to test all the. If you have ifs inside, then you need to do a change in an easy block. You need to test all the. I think it makes sense for Boost, for MPI, for other things that's very generic libraries and stable. But for my example is always TensorFlow. That is not generic. You cannot reuse the things in another application. The things that you do for TensorFlow are only for TensorFlow. So why bothering separating?
We're working on an easy block for TensorFlow.
Yeah, but I did my
one of the hardest ones we've ever done.
yeah, and I did a pull request 1 year ago, and it was not merged because it was not an easy block. So that's
because there you're hacking around too much.
okay. That's your point of view. So yeah, it was.
So we've had this discussion a lot of times. There's a thin line between easy blocks and easy config.
Yeah.
And it really depends on how proficient you are in Python and how clean you want to do things.
Yeah.
Whether you want an easy block or an easy config.
How lazy you are.
And how
lazy you are.
how lazy? Yeah. No, it depends on what. In the central repositories, we try to keep things clean, because if we don't, it's just going to explode in our face, and we're going to suffer.
Yeah, but define clean. That's the thing. Yeah.
But for side custom stuff, it may make sense. Just do whatever works for you, and if you can keep it maintained yourself.
Just a somewhat heretic comment that every single time we put an if inside an easy block, for me is a signal for needing a redesign how we do stuff. And I think this applies universally to almost all ifs. Maybe there are some exceptions, but think about it.
Yes.
Also related to what you said. Oh, sorry, there was somebody else. Because this is something different. So.
Mine is also different, but go ahead.
So on the last slide, you were actually mentioning OpenStack, HPC OpenStack system, and so I'm wondering how the integration with EasyBuild looks like. So basically, you provide the software packages in the in the virtual machines of the users, or what's the plan there?
So we are just starting there, so I cannot give any details. We just had access to the VM, so we are preparing the design. This was just food for thought for the next year, and if you're working on a similar thing, we can discuss offline.
But what would be really cool if you would deploy actually your own.
Challenge accepted.
Do it in easy config.
Now, one question on how you use Jenkins. So you said, if I understood it correctly, that Jenkins deploys software, and then once you test it, then it's deployed into production, or?
So it's the other way around. So there's the pull request
The
phase.
pull request is something that you manually tested before.
No. You don't need to test. You write an easy config file, you open a pull request, and then Jenkins will test it. So you just tell the name of the system, and Jenkins will build in a sandbox and say if it works on that machine.
All right.
Okay, this is one step.
And that is done in a sandbox. That is not deployed into
production. Nobody can see unless you do a module use that path. So
okay.
How do you share the software between your machines?
this is so this is the second step. We have a production file list where we have all the name of the EasyConfig files that we deploy in production with the prefix where we want to install, and then on each system Jenkins will read this file and deploy in production. So when you do a pull request and you want to install it in production, besides your EasyConfig file, you need to update this list of production EasyConfig files. It's a text file. So that's how it gets into production.
The actual deployment is automated.
Exactly. When the pull request is merged, Jenkins will see this list of this text file, and you try to install everything that is inside.
In the beginning, you showed that within the self-service portal, you were offering the service for the users that they could install or the code compilation. Can you show us how this works? So you just paste the config in there, or?
No,
What
this
does
is
it do?
just documentation. So this is our.
People how to use EasyBuild on their system.
Okay, I thought that it's self-service. You
No,
paste the
not.
config,
You're not yet there.
it deploys
Sorry.
your OpenStack, and then your application.
Built as a service.
Yeah.
Yes. Okay.
We're not far from there because they can do
Yeah.
a pull request and then.
Yeah.
Yeah.
Do you actually have users that send pull requests?
We had, yeah, not many because we never ask them to do it, but one found in the internet and he prepared a new version of something and we'd never advertised.
Security issue too?
No, they are.
If I open a pull request,
No, I need to say okay to test if you're not on the list.
that's a good idea.
If you're not whitelisted,
Then I won't test you automatically.
And maybe just one small thing related to what you said before about having this extra log with all the executed commands. That's something that we were discussing yesterday, that maybe it makes sense to have on the module itself, and when you do module help, to have an extra section, something similar to what Marcus has done last year, but having where the configure line and the build line, that might be useful as well. So every user knows, like, okay, so this has been built this way. It has what I need, or it doesn't. Because there's many cases it doesn't matter, but in some others, there's
it's
a lot
there,
of
it doesn't-
options that might be enabled or not. So
Yeah, it doesn't hurt, so yeah,
so
makes
the
sense.
only you have to be careful to don't make the output of the module help massive.
Yeah.
But that might be an idea. So
Yeah.
just something so it doesn't get missed.
Sure.
Yes. Yes. First, I want to thank you, Kenneth and John, to let us the occasion to share our point of view about EasyBuild. So I'm Laurent Nguyen. I work at CA with Xavier. As yesterday, you already know CA, so I will pass on the presentation. Just one thing about the cluster we are managing now. I work on 2 computing centers in one facilities, and for now we have 3 clusters.